One day, far beyond the reach of our lifetimes, far beyond the rise and fall of civilizations, far beyond even the death of our own sun, someone somewhere will ask a question that echoes through the cold darkness of the cosmos. What is the most terrifying thing this universe has ever created? But the truth is, the universe has never waited for us to ask. It has already built horrors so powerful, so violent, so incomprehensible, that if any of them drifted close to our fragile world, life itself would be erased before we even knew we were in danger. This is not science fiction. This is reality. These objects exist right now, in the black ocean above your head. Some of them are drifting through the galaxy unseen. Some are spinning so fast that the laws of physics bend around them. Some emit more power in a single second than our sun will produce in its entire lifetime. And some, if they turned their attention toward Earth, could sterilize our planet in less than the blink of an eye. Tonight you will see them all. But before we begin, you must understand something. The universe is not trying to harm you. It is not angry. It is not alive in the way we understand life. It is simply vast, ancient, indifferent. And in that indifference, it has forged monsters of unimaginable scale. So let me take you to a small, distant star. A star that died long ago. A star that should have faded quietly into darkness, but instead transformed into one of the deadliest objects known to science. A magnetar. Imagine a star collapsing into a sphere only a few kilometers wide, smaller than a city, but with a mass greater than our sun. Now imagine that this corpse of a star is spinning several times every second, wrapped in a magnetic field so intense that if you were to stand even 1,000 kilometers away, the magnetic force would rip the electrons off the atoms in your body. Your chemistry would fail. Your neurons would stop firing. Your very matter would fall apart. A magnetar does not kill you by heat, radiation, or impact. It kills you by unmaking you, tearing apart the very structure of reality you are made of. And here is the terrifying part. A magnetar once released a burst of energy so powerful, so violent that even from 50,000 light years away, it briefly damaged the instruments of satellites orbiting Earth. Now imagine that same burst happening 10 light years away, 1 light year away, 10 billion joules of energy, unleashed in less than a second, striking Earth with the fury of a star exploding directly in our sky. The oceans would boil. The atmosphere would ignite. Life would end instantly, and the magnetar would not even notice. It would simply keep spinning, alone in the cold dark, a cosmic executioner waiting for its next moment of violence. But magnetars are only the beginning. There are things far more violent than collapsing stars. Creatures of gravity so extreme that not even light can escape. Engines of destruction that twist space itself. And there are objects so bizarre, so ancient, so powerful that even the greatest cosmologists struggle to understand them. In the next moments, we will face them all. But before you see the most terrifying object in the universe, you must first understand something even darker. Sometimes the scariest things are not the ones that destroy you instantly. Sometimes the scariest things are the ones you never see coming. There is a kind of cosmic violence so sudden, so absolute, that if it happened in our part of the galaxy, nothing on Earth would survive long enough to even realize what took place. Long before we saw it, long before we felt it, long before the sky had time to glow, life would already be over. These are gamma-ray bursts, GRBs, the most powerful explosions the universe has ever created. Not supernovae, not black holes, not quasars, something far worse. Imagine a star 40 times the mass of our sun, collapsing in a fraction of a second. The core implodes, space tears, matter falls inward with such force that it rebounds into two hyper-focused beams of pure energy, jets so bright that for an instant they outshine the entire visible universe. One burst, one beam, one moment, and the fate of everything within thousands of light years is decided. Nothing can block a gamma-ray burst. No atmosphere, no magnetic field, no distance large enough to guarantee safety. If one were aimed at Earth, the first thing you would notice is nothing. No warning, no bright flash, no time to run. In the fraction of a second before your brain could process what happened, the burst would strip the ozone layer from the atmosphere, ignite nitrogen into toxic compounds, and trigger a mass extinction far worse than the one that ended the dinosaurs. And yet, this is not the terrifying part. The terrifying part is that gamma-ray bursts don't just kill planets. They erase them from history. They sterilize entire star systems. They wipe the slate of evolution clean. And all of this happens in silence across distances so immense that the objects causing the destruction have died billions of years ago. When astronomers first detected a GRB, they thought their instruments were malfunctioning. The energy was too much. The numbers were impossible, but they were real. Somewhere across the cosmos, a star had collapsed into a black hole and unleashed a cosmic scalpel sharp enough to slice through galaxies. Now imagine this. Somewhere in the vast dark between stars, a monster is pointing directly at us. A star on the verge of collapse. A cosmic executioner preparing its final act. Scientists believe there may be a candidate. WR104, a dying Wolf-Rayet star. A star caught in a beautiful spiral with its companion, like two dancers locked in a cosmic waltz. But beauty hides danger. WR104 is massive enough, unstable enough, and close enough to potentially send a gamma-ray burst directly toward Earth if it collapses. Will it? No one knows. It could happen tomorrow. It could happen in 1,000,000 years. It could never happen at all. And yet the uncertainty is exactly what makes it terrifying. Because gamma-ray bursts remind us of something we often forget. The universe does not revolve around us. It does not care about our stories, our civilizations, our hopes, our fears. It simply exists, and within its existence are forces so powerful, so indifferent, that human life means nothing to them. Gamma-ray bursts are not evil. They are not purposeful. They are simply inevitable, a natural outcome of a universe driven by gravity, pressure, and time. But if GRBs are the universe's snipers, silent, instantaneous killers, then what comes next is something different, something slower, something patient, something that kills not with a beam of light but with gravity itself. A monster that swallows space, devours time, and stretches reality until it breaks. A thing so terrifying that even light can't escape its grasp. And unlike a gamma-ray burst, this one can move. It can drift. It can hunt. And it may already be closer than you think. In the vast, endless dark between stars, there are objects that do not shine, do not burn, do not pulse with energy. They give off no heat, no radiation, no light. They drift in silence, invisible even to the most sensitive telescopes humanity has ever built. These are black holes, gravity made absolute, matter crushed beyond recognition, regions of space where the laws of physics surrender. You have heard of them. You have seen the animations. But what you have never fully understood, what most people never truly grasp, is that black holes are not just exotic cosmic objects. They are predators, driven not by hunger but by inevitability. Born from the corpses of massive stars, they roam the galaxy like dark ghosts, swallowing planets, stars, even other black holes, consuming everything unfortunate enough to cross their path. Imagine something that bends space around it so completely that your path forward becomes a spiral, dragging you inward even if you try to escape. Light itself curves, time slows, your future narrows into a single direction, downward into the abyss. And once you pass the event horizon, the point of no return, not even the universe can pull you back. But the most terrifying part is this: black holes are not stationary. They drift. They wander. Some are flung across the galaxy at millions of kilometers per hour. Some are ejected from galactic collisions like cosmic bullets. And some are moving silently through the Milky Way right now. Invisible, undetectable, approaching. In 2022, astronomers confirmed something they had long suspected. A rogue black hole, just one, was detected passing through the Milky Way, not bound to any star, drifting like a dark island in a sea of stars. There is no light to warn us, no glow to reveal its presence. It is a perfect sphere of nothing, sliding through the galaxy with only one signature, its gravity. And here on Earth, on this fragile world orbiting a yellow star, we would never know it was coming. No telescope could see it. No radar could detect it. Only when our solar system began to twist, when the orbits of outer planets warped, when comets shifted direction, only then would we realize that something ancient and hungry had arrived. And by that time, it would already be too late. But there is a black hole far more terrifying than rogue wanderers, a monster at the center of our own galaxy. Sagittarius A, a supermassive black hole 4 million times the mass of our sun, spinning at incredible speed, wrapped in a disk of hot plasma spiraling to its doom. If you could approach it safely, you would see something no human mind is prepared for: a glowing maelstrom of light, swirling around an abyss so dark it looks like the universe has been punctured. But the true horror is not the black hole itself. It is what surrounds it: stars whipping around at relativistic speeds, clouds of gas torn apart, objects stretched into thin filaments by tidal forces so violent they shred matter. And all of it happening in silence, because sound cannot travel through the vacuum of space. But even supermassive black holes are not the final stage of terror. What the universe hides in its shadows is far stranger. There are theories, supported by real observations, that some black holes may contain naked singularities, places where the rules of space and time collapse so completely that cause and effect break down. No horizon, no limit, just raw, unfiltered singularity exposed to the universe. If these exist, they are not just monsters. They are the end of reality itself. But the scariest truth about black holes is this: they grow. Every star they consume, every planet they devour, every collision between galaxies, all of it feeds them. And one day, long after humanity is gone, long after every star in the night sky has faded into darkness, black holes will be the last surviving giants of a dying universe. But even these titans are not eternal. There is a process, slow, silent, unstoppable, that gnaws at them, evaporates them, shrinks them, kills them. And what happens when the last black hole dies is something far more terrifying than anything you've seen so far. For most of cosmic history, black holes were seen as eternal, indestructible, unkillable, the final stage of matter, the ultimate cosmic prison, a place where everything falls in and nothing comes out. But then Stephen Hawking discovered something that shook the foundations of physics. Black holes do die, not violently, not with explosions, but in the quietest, slowest, coldest way possible, through a process now known as Hawking radiation. To understand it, imagine the emptiness of space. What looks like a perfect vacuum is actually a seething ocean of activity. Particles appear and disappear. Energy flickers in and out of existence. Quantum foam boiling at the smallest scales of reality. Near the edge of a black hole where gravity stretches space to its breaking point, these particle pairs form and something strange happens. One particle falls in, the other escapes. And with every escaping particle, the black hole loses a tiny bit of mass. It evaporates, slowly, relentlessly, inevitably. But here is the scale of that slowness. If you took a black hole with the mass of our sun, it would take 1067 years to evaporate. That is a number so large that your mind cannot grasp it. A number greater than the number of atoms in the observable universe. A time so long that every star will have died billions of times over, every galaxy will have dissolved, and the universe will have faded into a cold void. But Hawking radiation does something terrifying as a black hole shrinks. It speeds up. The smaller the black hole becomes, the faster it evaporates. For most of its existence, it fades slowly, gently, quietly. But when the end comes, it comes suddenly, violently, catastrophically. A final moment where the black hole, after trillions of years of consuming matter, explodes in a burst of energy brighter than a billion suns. A dying scream of gravity breaking free. This is the final fate of every black hole, every stellar mass black hole, every supermassive black hole, even the titans at the centers of galaxies. One day, the one anchoring the Milky Way, Sagittarius A, will shrink to the size of a mountain, then a pebble, then a dust grain, and then it will explode into pure radiation, leaving nothing behind. But here is the part that should unsettle you. When black holes die, they take the last sources of energy with them. Stars will already be gone. Planets will be cold, wandering rocks. Galaxies will have drifted apart. And black holes will be the final luminous objects in a dark, silent universe. Their death is the death of structure, the death of heat, the death of anything that could ever be called alive. When the last black hole evaporates, the universe will enter a stage that is more terrifying than any monster, any explosion, any cosmic threat we have encountered so far. A stage where nothing changes, nothing happens, nothing moves. A stage known as the heat death, when the universe reaches its final, absolute, eternal silence. But before we go that far into the future, there is something else you must see. Something that exists right now in the present-day universe. Something stranger than black holes, more powerful than neutron stars, more mysterious than dark matter, a form of matter that should not exist, and yet it might be out there, drifting through the cosmos like a silent infection, waiting for the right moment to transform everything in its path. There is a hypothesis in modern physics that describes something so disturbing, so unnatural, that if it were real, it would be the most dangerous substance the universe has ever produced. It is not antimatter. It is not dark matter. It is something far stranger, strange matter. And if even a single fragment of it were drifting through the galaxy right now, the fate of every star, every planet, even every atom in your body could be sealed. To understand strange matter, you must first understand that not all particles are created equal. What you call matter is simply a stable arrangement of quarks, up quarks and down quarks forming protons and neutrons. But deep inside neutron stars, where the pressure is so extreme that atoms collapse into a giant atomic nucleus, something extraordinary may happen. The quarks may rearrange themselves into a different structure, a more compact structure, a more stable structure. A form of matter so dense, so tightly bound that normal atoms cannot compete. This is strange matter, matter made of strange quarks. But here is where the horror begins. If strange matter is more stable than the matter you are made of, then ordinary matter is like a precarious tower of bricks standing next to a perfect crystal lattice. Touch them together, and the unstable structure collapses into the stable one. In other words, if a piece of strange matter ever contacts normal matter, It converts it. Electron by electron, proton by proton, atom by atom. A chain reaction that cannot be stopped. A process that transforms everything it touches into strange matter as well. This hypothetical particle called a strangelet could be smaller than a grain of sand, and yet if it touched Earth, it would begin a silent, unstoppable infection. You would not feel pain. You would not see destruction. There would be no explosion, no radiation, no heat. Your atoms would simply rearrange into a new form of matter. Your skin, your bones, the air, the oceans, the core of the earth, all quietly transforming into cold, dense, perfect, strange matter. In minutes, Earth would shrink into a sphere 200 meters across, a silent, featureless, ultra-dense orb drifting through space. No sound, no light, no survivors. And if this strangelet came from a neutron star, it might be nearly indestructible. It might survive supernovae. It might drift for millions of years. It might already be passing through the void between the stars of the Milky Way. The terrifying question is this: if strange matter is more stable than normal matter, why hasn't the universe already turned into it? The answer may be simple. Maybe strange matter doesn't exist, or maybe it does exist, but it is so rare that we have never encountered it. Or maybe, just maybe, the first strange star has already formed. A neutron star that collapsed not into a black hole, but into a strange star. An object smaller than a city, heavier than a mountain, shining faintly with ghostly blue light. A star that, if it collided with another neutron star, could spray strangelets across the galaxy like droplets of a cosmic virus. A virus that, in theory, could convert the entire Milky Way into a cold, dense sphere of strange matter. This is not fantasy. This is not speculation without evidence. Some neutron stars we have observed rotate so fast, shine so strangely, and behave so differently that scientists believe they may actually be strange stars. We may have already seen them, without realizing what they truly are. But even if strange matter does not exist, the universe has far darker things waiting for us. Objects so bizarre, so enormous, and so violent that they warp the very structure of galaxies. And one of them is brighter than 100 trillion suns. A lighthouse of cosmic destruction, burning across the universe with unimaginable power. Across the vast darkness of the universe, there are objects so bright, so violently luminous, that they outshine entire galaxies. Not millions of stars, not billions, trillions. Imagine a single point of light, tiny compared to the spiral arms surrounding it, yet shining so intensely that its glow can be seen across the observable universe. Over distances so extreme that light traveling at 300,000 kilometers per second needs billions of years to reach us. This is a quasar, the most powerful continuous energy source known to science. A quasar is not a star. It is not a supernova. It is the feeding mechanism of a supermassive black hole, a monster millions or even billions of times more massive than our sun. And when these giants begin to feast, The universe itself lights up with terrifying brilliance. Here's how it happens. At the heart of a galaxy, a supermassive black hole begins pulling in matter, gas, dust, stars, planets, anything that wanders too close. As matter spirals inward, it compresses and heats up to temperatures hotter than the surfaces of the hottest stars. The accretion disk becomes a glowing maelstrom of plasma, circling the black hole at near light speed. Friction turns into heat. Heat turns into radiation. And radiation turns into a blinding beacon, an engine of power so extreme that for a moment it becomes visible across the entire observable universe. But the horror of quasars is not their brightness. It is what their brightness means. It means destruction on a scale beyond comprehension. It means stars shredded by gravity. It means entire solar systems ripped apart atom by atom. It means the core of a galaxy collapsing into violent chaos. A quasar is a sign of a galaxy devouring itself. And here is the part that most people never realize. Quasars can aim. As the black hole spins, it generates twin jets of energy, streams of particles accelerated so violently that they pierce through space like cosmic drills. If one of these relativistic jets was pointed directly at Earth, even from billions of light years away, the effect would be catastrophic. The jet would strip away our atmosphere. The radiation would sterilize the surface. The oceans would boil into steam. And the planet would be left a lifeless, charred rock drifting in the dark. Thankfully, no known quasar is currently pointing at us. But this does not mean we are safe, because quasars grow, they evolve, they awaken. And when they awaken, everything around them changes. At the center of our own galaxy sleeps a supermassive black hole, Sagittarius A. It is quiet now, dormant, feeding only occasionally on drifting gas clouds and unlucky asteroids. But astrophysicists know something troubling. Every dormant supermassive black hole has the potential to become a quasar. Ours included. If a large enough gas cloud fell into the center of the Milky Way, or if our galaxy collided with another, a process guaranteed to happen when the Andromeda galaxy approaches us, our black hole could awaken. And when it does, the center of the Milky Way would ignite into a blinding quasar, unleashing jets, radiation, and destruction across thousands of light years. Earth might survive, or it might not. But survival would depend entirely on one thing: the direction of the jets. If they point even slightly toward us, life on this planet would be over. But quasars are not the largest monsters the universe has created. There exists something bigger, stranger, something that defies the very idea of what a galaxy is, a star is, even what matter is. Enormous structures that form not from gravity or collisions, but from something far more ancient, something embedded in the universe from the moment it was born. And these structures might be the closest thing our universe has to cosmic scars, leftovers from a time before atoms, before stars, before galaxies, before light, long before stars ignited, long before galaxies spiraled into form, long before atoms existed. The newborn universe was a violent, expanding sea of energy and chaos. Space itself was hot, turbulent, unstable, stretching and cooling in the first fractions of a second after the Big Bang. And in that violent expansion, something may have gone wrong. Or rather, something may have been left behind. Defects, imperfection, seams in the fabric of reality. As if the universe in its first moment cooled too quickly and cracked. These cracks are known as cosmic strings. Not strings like threads, not strings like wires, but infinitely thin, unimaginably dense faults in space-time itself, relics from the earliest universe. If they exist, they are the most dangerous objects in all of creation. A cosmic string has no width. It is thinner than an atom, thinner than a proton. It is a line of raw, compressed energy with the density of an entire mountain packed into a segment shorter than a human cell. You cannot see it. You cannot feel it. You cannot detect it until it passes near you. And if it does, its gravitational field would slice through everything in its path like a cosmic scalpel. Not because it cuts, but because space curves so sharply around it that anything crossing its path is torn apart by tidal forces. If a cosmic string passed through Earth, the planet would be split cleanly in half in a fraction of a second. No explosion, no sound, just a silent dividing line as the string swept through space, continuing forever, leaving two drifting pieces of Earth behind like broken shells. But the true horror of cosmic strings is not in what they destroy. It is in what they do to the universe itself. A cosmic string can create gravitational lensing so extreme that background galaxies appear duplicated, stretched, or twisted into impossible shapes. If two cosmic strings intersect, they create a kink, an event so violent it could generate bursts of gravitational waves powerful enough to be detected across galaxies. And if a cosmic string loops, creating a closed shape, it vibrates like a cosmic guitar string, radiating gravitational energy until it shrinks, tightens, and eventually tears itself apart, unleashing a catastrophic burst of energy. Scientists have searched for cosmic strings for decades. Some believe we've already seen hints, strange gravitational anomalies, unexplained lensing effects, unusual patterns in the cosmic microwave background. Others argue they don't exist at all. But here is the chilling part. If cosmic strings exist, they are not rare. They would stretch across the universe in vast networks, some spanning galaxies, some stretching across the observable universe itself. And if even one passed through our solar system, it would not slow down, it would not change course, it would not care. It would simply carve through planets, moons, the sun, and space itself, leaving behind a wake of gravitational distortion, a cosmic wound. But these relics of the early universe are not the only structures lurking in the darkness. There are voids, regions of space so vast, so empty, so disturbingly silent that they defy every expectation we have about how the universe should look. Places where galaxies should exist, but do not. places where something seems to be missing, places that should not exist, and yet they do. There are places in the universe where stars burn, collide, and die, where galaxies swirl in luminous storms, where black holes devour light and quasars ignite the darkness with unimaginable fury. And then, there are places where none of that exists, places where the universe itself seems to hold its breath, places where creation simply stops. The Boötes Void is one of those places, a region so vast, so empty, so profoundly silent that astronomers who first discovered it thought their instruments were broken. A sphere nearly 330 million light-years across, containing almost nothing. To understand that scale, imagine a cosmic bubble so large that if the Milky Way were placed at its center, not a single visible galaxy would appear within hundreds of millions of light-years in any direction. Just darkness, just emptiness, just silence. The human mind cannot grasp such a void. It is too big, too empty, too wrong, because the universe should not look like this. Galaxies cluster. Gravity binds them. They form filaments and wall, threads of light woven across cosmic space. But the Boötes Void is an absence, a hole in the cosmic web, a place where structure failed, a place where gravity forgot, a place where something went missing. Researchers once described it as a giant cosmic cave, a hole in the universe where entire superclusters should exist but do not. Some galaxies hang inside it like tiny lanterns scattered across a vast, endless cavern. But their presence only deepens the mystery. How did these galaxies get here? Were they formed inside the void alone? Were they pulled in? Or did the void grow around them, swallowing structure as it expanded? One theory suggests an ancient collision, two massive voids merging into one, erasing whatever existed inside. Another proposes something far more unsettling, that the Boötes Void may be a region where dark energy behaves differently, pushing matter away faster than the surrounding universe. If true, then the void is not empty because nothing formed there. It is empty because something forced everything out. And then there is the darkest idea of all, the idea that the Boötes Void might be a relic from a time before galaxies existed, a region of primordial emptiness, an ancient scar from the universe's chaotic birth, a place where the early cosmos cooled unevenly, leaving behind a wound in space-time that never healed. But the truth is even more terrifying when you consider what voids represent. They are not empty spaces between galaxies. They are the dominant structure of the universe. Everything we see, all stars, all planets, all galaxies, exist only in thin, fragile filaments stretched across unimaginable oceans of nothingness. We do not live in a universe filled with galaxies. We live in a universe filled with voids, dotted with rare islands of light. The Boötes Void is simply the largest reminder of that truth. A reminder that the universe is fundamentally cold, dark, and empty, and that the light we cling to is the exception, not the rule. But the Boötes Void is not the only cosmic abyss haunting the night. There exists another, a void deeper, stranger, colder, one that affects the very temperature of the universe, a void so powerful that it leaves an imprint on the afterglow of the Big Bang itself, a void that should not exist unless something unimaginable created it. Some horrors in the universe can be seen: blazing stars, exploding supernovae, roaring quasars, colliding galaxies. But others hide not in their brilliance, but in their absence, in the quiet, unnatural places where the universe behaves in ways it should not. And among all the strange and empty regions of space, one stands above the rest, whispering a disturbing secret about the nature of reality itself: the Eridanus Supervoid, a region so vast and so cold that it has left an imprint on the oldest light in the universe, the cosmic microwave background, the afterglow of the Big Bang. This afterglow should be smooth, even, uniform, a gentle radiation filling space with almost identical temperature in every direction. But in the constellation Eridanus, there is a cold spot, a region where the temperature dips lower than the surrounding space by a margin far too extreme to be explained by randomness. Something enormous had to cause it, something ancient, something powerful. And when astronomers traced the region in 3 dimensions, they found it: a supervoid nearly 1 billion light-years across, a chasm in the cosmos so immense that even the Boötes Void looks small by comparison, a hole in the universe where there should have been galaxies, clusters, superclusters, a vast cosmic desert stretching farther than anything humanity has ever observed. But why is it so cold? Why is it so empty? Why does this region of space drain energy from the cosmic microwave background itself? One explanation suggests something simple: the void is so large that light traveling through it loses energy as it climbs out of its gravitational well. But this does not fully explain the anomaly. The temperature dip is too deep, too sharp, too unnatural. Other theories wander into darker territory. Some physicists believe the Eridanus Supervoid might be the signature of a collision between our universe and another bubble universe in a cosmic multiverse. If such a collision happened in the early moments after the Big Bang, it would have left behind a scar, a massive cold region where the fabric of spacetime was disturbed by contact with another cosmos. Imagine 2 expanding universes touching, like soap bubbles in a cosmic foam. The edge of the collision freezes the temperature, warps the structure, leaves behind an imprint that persists for billions of years, a cosmic bruise, a mark of another reality. Others argue something stranger. Perhaps a massive clump of dark energy sits inside the void, pushing galaxies away faster than normal, creating an expanding region of nothingness, a repulsive patch of vacuum, a region where the fundamental laws behave differently. And then there is the most unsettling possibility of all: the void may not have formed naturally. It may be the result of something, some unknown process that actively erased structure, a region where something consumed or displaced matter during the universe's earliest moments, long before stars were born. something the universe has hidden beneath billions of years of expansion, something we do not understand, and perhaps never will. Whatever the cause, the Eridanus Supervoid forces us to confront a truth we often try to ignore. The universe is not uniform. It is not balanced. It is not predictable. It is a patchwork of violence and silence, of brilliant light and endless empty darkness. And in that darkness, in those voids, lie the greatest mysteries of all. But while voids and cosmic strings are terrifying in their scale and emptiness, there exists a different kind of horror, one far more personal, far more immediate. A form of destruction that does not come from emptiness, but from overwhelming presence. From stars so massive, so unstable that their deaths can reshape entire regions of space. And one of them is staring right at us. Across the night sky, there are stars so large, so swollen with fire and pressure, that they defy everything you think you know about the cosmos. These are not stars like our sun. They are titans, red supergiants, hypergiants, cosmic monsters so enormous that if one were placed where our sun is now, its surface would extend past Mars. And among all these giants, one star stands above them as both a beacon and a warning. Betelgeuse, the red shoulder of Orion, a star that has been dying for hundreds of thousands of years, its outer layers trembling, pulsing, collapsing, expanding like a massive heart struggling to beat. And one day it will fail. And when it does, the universe will witness an explosion so bright it may outshine the full moon. But this is not what makes Betelgeuse terrifying. What makes it terrifying is what lies behind the calm glow we see from Earth, a core under unimaginable pressure, fusing elements like a cosmic furnace racing toward the end of its life. Every supergiant star lives fast and dies violently. As its core burns heavier elements, carbon, neon, oxygen, silicon, the fuel runs out faster, each stage lasting shorter than the one before it. Eventually, the star begins fusing iron, and that is the beginning of the end. Iron cannot release energy when fused, and once iron fills the core, the star collapses under its own weight in less than a second. Gravity wins. The core implodes, a shockwave forms, and then a supernova, a burst of light brighter than entire galaxies, a blast so powerful it can sterilize star systems tens of light years away. The outer layers of the star are thrown into space at a significant fraction of the speed of light. Radiation floods nearby regions. Neutrinos pour out in unimaginable quantities. And at the center, a new object is born, a neutron star or a black hole. This is the fate awaiting Betelgeuse. But here is the part that chills astronomers. Betelgeuse is unstable. Its dimming event in 2019 shocked the world. The star faded by nearly 25%, as if the universe had pressed a cosmic dimmer switch. Some believed it was about to explode. Others saw it as a sign of internal chaos. Convective cells rising and falling, dust forming in its outer layers, the final spasms of a dying star. But the truth is simple: Betelgeuse will explode. We just don't know when. It could be 100,000 years from now. It could be tomorrow. It could be happening already and the light simply hasn't reached us yet. When it finally collapses, the night sky will change. For months, even in daylight, Betelgeuse will be visible. A new star, burning so bright you could read a book beneath it. But this is a peaceful distance for us. Betelgeuse is too far away to harm Earth. The real monsters are the supergiants we don't see, the stars hidden behind dust, the titans farther across the galaxy, whose deaths might send gamma-ray bursts or streams of radiation toward us. And among them are true cosmic horrors. Stephenson 218, a hypergiant so massive that it dwarfs even Betelgeuse. Stars that burn their fuel in a furious frenzy and collapse before their galaxies have even aged. Stars so unstable that they could detonate at any moment. Stars whose deaths could trigger shockwaves powerful enough to reshape their cosmic neighborhoods. These are the engines of destruction, the cosmic bombs, the short-lived giants that burn bright, die fast, and leave devastation in their wake. And yet, even these titans are not the strangest objects the universe has forged, because beyond them lies something colder, denser, harder, objects so extreme that a teaspoon of their material outweighs mountains, stars that spin like cosmic drills, stars that trap light, stars that break the rules of physics. And the next one is unlike anything you can imagine, a star that is not truly a star, but something far more violent. In the aftermath of a supernova, when the titanic blast fades and the shattered layers of a dead star drift into darkness, something far stranger is left behind. A corpse, a remnant, a stellar heart crushed so violently that atoms themselves collapse. Electrons are forced into protons. Matter implodes into a single, dense soup of neutrons packed tighter than anything else in the universe. This is a neutron star, an object no wider than a city, but heavier than our entire sun. A teaspoon of its matter outweighs a mountain. The density is incomprehensible, the gravity unimaginable. If you stood a few kilometers above its surface, your body would be stretched thinner than a strand of DNA, torn apart by forces trillions of times stronger than Earth's gravity. But the true horror of neutron stars is not their density. It is their speed. When a massive star collapses, its rotation increases dramatically, like a spinning ice skater pulling in their arms. A star that once rotated once every few weeks can suddenly spin dozens, hundreds, even thousands of times per second. These are pulsars, neutron stars that rotate so fast they sweep beams of radiation across the universe like cosmic lighthouses. If one of these beams were ever aligned with Earth, even from vast distances, the radiation could fry satellites, disrupt atmospheres, or sterilize entire planets. Imagine an object heavier than the sun, smaller than Manhattan, spinning 716 times every second. That's the record holder we know of, PSR J17482446 AD. At this speed, The surface moves faster than sound, faster than bullets, faster than hurricanes, approaching a significant fraction of the speed of light. And as the star rotates, mountains on its surface, mountains no higher than a few millimeters because gravity crushes everything, create tiny distortions that ripple across space-time. Gravitational waves radiate outward like the death throes of a cosmic engine. But this is only the beginning. Neutron stars possess magnetic fields billions of times stronger than Earth's. These fields twist and snap like taut cosmic wires, accelerating particles to unimaginable energies. Some pulsars unleash so much radiation that they carve cavities in the gas around them, bubbles of death hundreds of light years wide. And then there are magnetars, neutron stars with magnetic fields strong enough to erase matter, strong enough to distort atoms, strong enough to tear apart chemical bonds from thousands of kilometers away. One magnetar burst in 2004 from the star SGR 180620, released more energy in 1/10 of a second than our sun emits in 100,000 years. And we were lucky. It happened on the other side of the galaxy. If it had been even 10 times closer, life on Earth might have ended instantly. But neutron stars hide an even stranger secret. Sometimes two of them collide. When they do, they spiral together in a deadly dance, radiating gravitational waves that warp spacetime itself. Their crusts crack, their magnetic fields lash out, their cores fuse, and in a final explosive moment, they produce something the universe treasures above almost all else: heavy elements. Gold, platinum, uranium, the ingredients for planets, for technology, for life. And in that instant of creation, they produce a blast brighter than 100 billion stars, kilonova. A collision so powerful that telescopes across Earth trembled as they recorded it. A reminder that even the most terrifying objects in the universe are also creators. But some neutron stars do not follow the rules. Some blur the line between neutron star and black hole, objects so dense we cannot be sure what they are. Exotic matter, quark stars, strange stars, remnants more alien than anything in our imagination. And somewhere out there, drifting in the cold space between galaxies, the universe hides the most terrifying version of all. A neutron star traveling fast enough to slice through entire solar systems like a cosmic blade. A rogue pulsar. A spinning, radioactive knife of unimaginable density and speed. And if it ever passed through our region of space, nothing could stop it. But even neutron stars, with all their power and density and violence, are not the universe's final horrors. Because beyond them lie objects that warp reality itself, objects that ripple through space-time, objects that do not destroy matter, they destroy the idea of space, of time, of past and future. And one of them may have passed through you already without you even knowing. Space looks silent, empty, calm. When you look at the night sky, you imagine a vast stillness stretching between the stars, an infinite black ocean undisturbed by anything except light. But the truth is far stranger. Space is not calm. Space is not still. Space is a restless, vibrating fabric, endlessly shifting, bending, warping under the weight of cosmic events so powerful that their echoes travel across the universe. These echoes are gravitational waves, ripples in spacetime itself, not waves of light, not waves of sound, waves of reality. When two massive objects like neutron stars or black holes collide, they don't just release energy. They deform the universe. They send out vibrations that stretch and compress everything in existence. You, the Earth, the Moon, the orbit of every planet, the atoms in your body. When the first gravitational waves were detected in 2015, the signal was so faint that it changed the length of the detector's arms by less than 1/10,000th the width of a proton. Something so small it should be impossible to measure. And yet, the event that caused it was anything but small. Two black holes, each dozens of times the mass of the sun, spiraling inward at half the speed of light before merging in a final burst of pure gravitational energy. The universe shook, and we felt it. But here is the part most people never hear. Some gravitational wave events are so massive, so violent, that if you could see spacetime itself, it would ripple like the surface of a stormy sea. Black hole collisions hundreds of times larger, neutron stars tearing each other apart. Entire galaxies merging in slow, unstoppable motion. And somewhere out there, beyond the reach of our detectors, there may be objects capable of producing waves powerful enough to shatter the fragile structures of the universe. Cosmic strings snapping, primordial black holes collapsing, dark matter clumps smashing together in ways we cannot imagine. But the truly terrifying thing about gravitational waves is not what they come from. It is what they can do. A strong enough wave, one produced by a collision between supermassive black holes millions of times more massive than the Sun, could disturb the very architecture of spacetime. It could stretch orbits, distort planetary systems, send stars drifting, collapse gas clouds, and over billions of years reshape the structure of entire galaxies. And on a much smaller scale, one of these waves might have already passed through you. Gravitational waves move across the universe constantly, flowing through galaxies like invisible tides. Every second, dozens, maybe hundreds pass through Earth. You cannot feel them, you cannot see them, but they stretch you, compress you, change your height by infinitesimal fractions. Your bones, your organs, your atoms. Everything you are is being rhythmically pulled and pushed by the distant deaths of stars. Even more disturbing is this. Some theorists believe that gravitational waves from the early universe, the first second after the Big Bang, are still passing through us, carrying information from a time before matter existed. Ripples from the birth of time itself. If we ever detect those ancient waves, we might learn what the universe looked like before atoms formed, before light, before structure, before everything. But there is a darker idea, a possibility that keeps physicists awake at night. If the universe is filled with invisible collisions and ripples that distort reality, what happens if one of those ripples carries with it something else? What if, hidden within gravitational waves, there are clues about objects we cannot see but can feel, massive structures drifting through the universe like ghosts? There are cosmic shadows out there, objects that do not emit light, objects that do not collide with matter, objects that bend space-time subtly, quietly, invisibly. And one of them may be passing through our galaxy right now. A dark wanderer, a primordial relic, a black hole older than the stars. Before the first star lit the darkness, before galaxies began their slow spiral dances, before atoms settled into the structures we now call matter, the universe was a storm, an expanding sea of energy and chaos, dense beyond comprehension, hot beyond imagination, turbulent beyond anything physics has yet been able to fully describe. And in that first instant, before a millionth of a second had passed, something extraordinary may have formed, not from collapsing stars, not from dying giants, but from the universe itself. These are primordial black holes born not in death but in birth. In the earliest moments after the Big Bang, regions of density varied. Some areas contained slightly more energy, slightly more mass. And if any of these fluctuations were large enough, gravity could have overwhelmed expansion, causing tiny pockets of the newborn universe to collapse into miniature black holes. Some might be the size of mountains, some the size of planets, some the size of atoms, and some smaller still. These ancient shadows of creation would not emit light. They would not glow. They would not orbit stars or interact with matter except through gravity. They would drift silently through the universe, invisible, undetectable, untouchable. And yet they could be everywhere. Tens of billions of them, hundreds of billions, perhaps even making up the mysterious dark matter that shapes galaxies and drives cosmic evolution. If primordial black holes are real, the Milky Way may be filled with them, passing through space like ghosts, occasionally slipping through planets, moons, and stars without leaving any visible trace. A black hole the size of a grain of sand could weigh as much as a mountain. One the size of a marble could pass straight through Earth without slowing down, entering through one side, exiting through the other, leaving behind nothing but a microscopic trail of gravitational damage. You would not feel it. The planet would not tremble. No alarm would sound. It would happen silently, invisibly, instantly. But if a larger primordial black hole, one with the mass of a small asteroid or a moon, ever wandered too close to our world, the result would be catastrophic. It would pull the crust upward as it passed beneath the surface, rip oceans out of their basins, distort gravity, tear continents apart. And if it were even slightly more massive, Earth could be torn in half before anyone realized what was happening. But the terror does not end there. Some primordial black holes may not be stable. If they are small enough, Hawking radiation would slowly evaporate them over billions of years. And when a primordial black hole reaches the end of its life, it explodes, not with fire or light, but with pure radiation. A final detonation that could sterilize worlds and shred atmospheres if it occurred nearby. A cosmic landmine drifting silently through the galaxy, waiting eons for the moment it reaches its critical end. Scientists have searched for these events. Some unexplained gamma flashes might be exactly that, the last screams of ancient black holes formed before stars existed. But the strangest possibility is one that twists the mind. What if primordial black holes were not just scattered across the universe, but woven into it? What if they seeded the first galaxies? What if supermassive black holes at the centers of galaxies, including the one anchoring the Milky Way, began not as collapsing stars, but as primordial singularities that grew over billions of years? If so, the heart of our galaxy is older than the stars around it, older than the atoms in your body, older than the laws of physics as we know them, a relic of creation still pulsing at the center of our cosmic home. And yet, even primordial black holes pale before another concept, another terrifying possibility. That dark matter itself, the invisible structure holding the universe together, might be something stranger, something colder, something that passes through us every second, something that could reshape the fate of galaxies without ever once touching a single atom. All the stars you see in the night sky, every galaxy, every planet, every nebula, every atom, make up less than 5% of the universe. 5%. Everything else, everything that shapes galaxies, everything that sculpts the cosmic web, everything that holds the universe together is invisible, untouchable, undetectable except through gravity. This unseen mass forms the true structure of the cosmos. It is the skeleton of the universe, and it is called dark matter. For decades, scientists tried to understand why galaxies spin too fast, why stars at the edges don't fly off into space, why clusters of galaxies behave as if they contain far more mass than we can observe. And the answer was disturbing. Something invisible is there, something silent, something massive, something that outnumbers normal matter 5-1. We do not know what dark matter is. We do not know what it is made of. We do not know where it came from. But we do know this: it surrounds you right now. Every second, trillions of particles, if they are particles at all, are passing through your body, through the Earth, through the moon, through the sun, through the galaxy itself. If dark matter were normal matter, you would feel it like a storm, but you feel nothing, because dark matter does not collide, does not react, does not glow. It slips through atoms like ghosts through walls. Entire galaxies swim through oceans of it, their shapes sculpted by gravity alone. And yet, for something so silent, so passive, so invisible, dark matter has a darker side. If dark matter consists of exotic particles, WIMPs, axions, or something yet undiscovered, they might occasionally collide with normal atoms. Not enough to cause destruction, not enough to heat the air or shake the ground, but enough to reveal something terrifying, Dark matter is not evenly distributed. It forms halos, streams, rivers, filaments, invisible structures stretching across the universe like the branches of a cosmic tree, guiding the formation of every star and galaxy. And within these filaments may lie dense clumps, cold, heavy concentrations of dark matter drifting silently through space. If Earth ever passed through one of these clumps, our planet would experience a gravitational disturbance strong enough to alter the orbits of asteroids, shift the paths of comets, and destabilize the delicate balance of the solar system. Tides would change, seasons would warp, even the motion of the moon could shift, and we wouldn't see the cause, we wouldn't detect the object. There would be no warning, just subtle changes until the consequences became unavoidable. But the most chilling theories suggest something far darker. Some physicists believe dark matter could interact with itself, colliding, merging, forming invisible galaxies parallel to the ones we see. A shadow universe, a cosmic mirror built from matter we cannot touch. If this is true, then right now, where you sit, where you breathe, where you exist, there may be an entire invisible galaxy overlapping with ours. Stars made of dark matter, planets of dark matter, structures passing directly through us without contact. A whole universe inside our universe unseen. And there is an even stranger idea. That dark matter might collapse under its own gravity, not into stars, not into planets, but into black holes. Ancient black holes formed not from dying stars, but from interacting clouds of dark matter. Invisible black holes, drifting silently through the cosmos. Black holes that would pass through solar systems without leaving any glow, any signal, any trace except for the gravitational wake they carve through space. Some astronomers believe these invisible black holes might be everywhere. Some believe they might be the very seeds around which galaxies form. Some believe they might have passed through the early Earth, shaping the course of life in ways we will never understand. But there is one thing scientists agree on. Whatever dark matter is, it is not gentle, it is not safe, it is not empty. It shapes galaxies, it guides cosmic evolution, it holds the universe together, and yet it remains completely unknown. But dark matter is only half the story. Because if something unseen holds the universe together, then something even more mysterious and far more terrifying is ripping it apart. If dark matter is the invisible skeleton holding the universe together, then dark energy is the force tearing it apart. A mysterious pressure, a cosmic repulsion, a silent expansion pushing galaxies away from each other faster and faster with each passing moment. It is the most powerful phenomenon in existence, strong enough to overwhelm gravity itself, strong enough to reshape the universe on the grandest scales. And yet we do not know what it is. Not a particle, not radiation, not a field we can measure. It is simply there. A force woven into the fabric of space-time, accelerating the expansion of the cosmos. To understand the terror of dark energy, imagine this. Every second, every galaxy in the universe is drifting farther away from every other galaxy. The space between them is stretching. Light traveling from distant stars is being pulled, stretched into longer, redder wavelengths. The universe is not just expanding, it is accelerating. And that acceleration will not stop. Not tomorrow. Not in 1,000,000 years. Not in 1,000,000,000,000. It will continue forever. Over time, the expansion will become so extreme that galaxies will slip beyond the observable horizon, disappearing into darkness. Then clusters will vanish. Then superclusters. Eventually, only a handful of galaxies will remain visible from any point in the universe. And long after that, even those will fade. The universe will become a vast ocean of cold, empty darkness, every island of light isolated beyond hope of contact. But the true horror begins when you realize what dark energy is doing on a deeper level. As space expands, energy density remains constant. That means there is more dark energy today than yesterday, more tomorrow than today, and more still in every future moment. Over unimaginable stretches of time, dark energy will dominate everything. Stars will die. Galaxies will dissolve. Even matter itself will fade as expansion stretches the universe toward absolute emptiness. And if dark energy grows stronger, if its acceleration rate ever increases to a value greater than cosmologists expect, the consequences become apocalyptic. This hypothetical scenario is called the Big Rip. In the Big Rip, the expansion rate increases so dramatically that gravity breaks down. Galaxies fly apart. Solar systems unravel. Planets escape their orbits. Stars are torn from the inside out. Eventually, atoms themselves are pulled apart. Protons, electrons, neutrons, all ripped from existence by the accelerating expansion of space-time. In this future, the universe does not end in fire or cold. It ends in disintegration, in shredding, in dissolution. Every structure, every particle, every quantum field stretched until nothing remains but a thin, cold smear of expanding vacuum. But even if the Big Rip never comes, dark energy still determines our fate. In a universe dominated by expansion, everything becomes isolated. Every region becomes its own island. Communication becomes impossible. Light cannot travel far enough to bridge the growing emptiness. Civilizations, if they exist at all in the distant future, will be trapped in cosmic cages, unable to see the universe that once existed beyond their local cluster. They will live in a universe of fading light, shrinking horizons, and endless dark. And eventually, they will disappear entirely. But dark energy, strange matter, black holes, and cosmic voids are only pieces of the puzzle. Because the most terrifying truth in the universe is not what exists now. It is what comes next. The long future, the slow death of everything. The final ages of time when the last stars burn out, the last galaxies fade, and the universe descends into its absolute end. Stars are the engines of the universe. They forge elements, heat planets, sculpt galaxies, and illuminate the darkness. But stars are not eternal. Every star, from the smallest red dwarf to the largest hypergiant, carries within it a countdown, a finite supply of fuel that determines its life, its death, and the fate of everything orbiting it. And as the universe ages, that fuel begins to run out. The majestic era of starlight, the age that allowed galaxies to shine and life to emerge, is already closer to its end than its beginning. The first stars that ever existed, the massive population III stars, died billions of years ago, collapsing into black holes and seeding the early cosmos with heavy elements. The bright blue giants that dominate young galaxies burn fast and die young, living only millions of years before exploding in spectacular supernovae. And even the sun, the comfortable, stable star that sustains every breath you take, is halfway through its life. But the end of stars is not sudden. It is slow, inevitable, relentless, and it marks the transition into something far darker. Imagine a future where galaxies dim. The brilliant arms of the Milky Way begin to fade as bright, massive stars disappear. The once crowded night sky becomes sparse, with fewer and fewer points of light. Red dwarfs, the longest-lived stars in the universe, continue to burn, faint, cool, dim for trillions of years. But even they cannot burn forever. Eventually, the smallest stars will exhaust their hydrogen and become cold, dark remnants. Black dwarfs, stars that no longer shine. The universe will become a graveyard of stellar corpses. White dwarfs will cool into darkness. Neutron stars will fade. Black holes will wander through an increasingly empty cosmos, waiting for their own distant deaths through Hawking radiation. This era, the era dominated by living stars, is temporary. The true fate of the universe is darkness. As time stretches beyond human imagination, galaxies will stop making new stars. The cold gas needed for star formation will be used up, locked away in stellar remnants, planets, and dead systems. When the final generation of stars flickers into darkness, the universe will enter the black era, a time when starlight no longer exists, a time when the cosmos becomes a vast ocean of cold, silent, lightless void. But before that darkness fully settles in, something even stranger will occur. As galaxies drift farther apart due to dark energy, starlight from distant regions will no longer reach us. The night sky will not fade because stars are dying. It will fade because the universe itself is stretching the light away, hiding galaxies beyond the cosmic horizon. In this distant future, any civilization unlucky enough to exist will see a sky devoid of galaxies. They will live in a cosmic cage, isolated, alone, surrounded by darkness, unable to see the true universe that existed billions of years before them. They will believe the universe is small, empty, lifeless. They will never know the truth. But on even longer timescales, the very concept of star disappears. Brown dwarfs, failed stars, may collide and briefly ignite into new stars. But even this last spark of stellar creation will eventually cease. The universe will become colder, emptier, more quiet, more still, Gravity will draw dead stars together. Black dwarfs, once glowing embers of white dwarfs, may collide and explode in rare thermonuclear events, adding momentary flashes to an otherwise dark cosmos. But these flashes will grow rarer, and then they will stop. And when the last star dies, the universe will enter a new age, one defined not by heat or light or energy, but by the slow decay of matter itself. Because after stars fade and galaxies dissolve, the most terrifying transformation of all will begin. The era when atoms themselves start to fall apart, long after the last star has burned out, long after galaxies have dissolved into cold clouds of drifting remnants, long after even black holes have begun their slow evaporation, the universe enters a new and final chapter. A chapter where the very building blocks of reality, atoms, begin to fall apart. For billions of years, matter helped shape the cosmos. Atoms formed stars. Atoms formed planets. Atoms created life. But even atoms are not eternal. The proton, long considered a symbol of stability, may not last forever. According to some theories, protons decay over unfathomably long timescales, 1032 years, 1036 years, perhaps even longer. But no matter how staggering that number is, it is still finite. And that means one day, every atom in the universe will die. Imagine this distant future. The cosmos is dark. There are no stars, no galaxies, no light except for the faint glow of evaporating black holes. The universe has cooled to near absolute zero. Dead stars, now black dwarfs, float in the void like frozen cinders. Planets wander alone, their surfaces colder than the deepest interstellar space. Neutron stars sit as silent monuments to a long-dead era of fire. And scattered through this darkness are atoms, trillions upon trillions of them, remnants of worlds, stars, dust, and life that once existed. But as time passes, even these atoms begin to break down. A single proton decays, a quark transforms. A particle disappears in a flash of radiation, then another, and another. Slowly, silently, inevitably, matter dissolves, not through collision, not through destruction, but through the gradual unraveling of the laws that once held it together. The decay begins in objects of all sizes. Black dwarfs crumble into dust. Dust dissolves into subatomic fragments. Subatomic particles decay into even smaller, more ephemeral forms. And those too fade away. The universe becomes thinner, diluted, empty. Matter, once the architect of galaxies, becomes a rare visitor in a cosmos dominated by nothingness. Over unimaginable spans of time, even the heaviest remnants, iron cores, planetary debris, neutron-rich fragments, disintegrate. What remains are photons and neutrinos, drifting endlessly through an ever-expanding void. But the story goes deeper. If proton decay is real, then matter's end is not just a fading, it is a transformation, a mathematical certainty, a future baked into the structure of existence. It means that nothing, no planet, no star, no molecule, no particle, will survive forever. And yet, even in this near-empty universe, strange structures can still form. quantum fluctuations still exist. Virtual particles still appear and vanish. Pockets of energy flicker in the darkness like ghosts of a universe long gone. But these flickers will never become matter, never become stars, never become life. They are echoes, shadows, memories. And even these memories fade as the universe expands beyond comprehension. Distances stretch, energy thins. Time becomes a meaningless ocean that flows endlessly forward without change. But even after matter has died, the universe itself still has one more stage. The last, coldest, darkest age. An age where not even black holes remain, and the universe becomes a vast, silent expanse of near-nothingness. The era of pure space-time. The era of entropy's final victory. The era when the universe is not just darker but dead. After the stars fade and matter decays, after galaxies dissolve and atoms fall apart, only one kind of object will remain to haunt the darkness: black holes. They will be the last giants of the cosmos, the final monuments to everything the universe once was. Scattered across an ocean of cold, empty space, supermassive black holes, billions of times the mass of the sun, will drift through the darkness like silent gods. No longer feeding, no longer surrounded by glowing accretion disks, no longer tearing stars apart. They will simply exist, immense, cold still. But even black holes are not eternal. They too decay, slowly, painfully slowly, through a mechanism so delicate and subtle that it takes longer than entire eras of cosmic history combined. Hawking radiation. For eons beyond imagination, black holes evaporate at a pace so slow it defies comprehension. A black hole with the mass of a star may take 1067 years to evaporate. A black hole with the mass of millions of suns may take 10,100 years. And the largest black holes in the universe, the supermassive titans at galaxy centers, could take up to 101,000 years to vanish. That is a number so enormous it stretches meaning itself, longer than the age of the universe, longer than the lifespan of matter, longer than the lifetime of time as we understand it. But eventually, even these monsters begin to shrink. Their event horizons tighten, their gravitational pull weakens, their mass evaporates into faint, ghostly radiation leaking out over unimaginable stretches of time. For almost their entire existence, they fade gently, quietly. But in their final moment, everything changes. The evaporation accelerates. The last fraction of a second erupts into a blinding explosion of pure energy, a flash in the eternal darkness. The final scream of a dying giant. A supermassive black hole, after surviving the deaths of stars, galaxies, and matter itself, ends in a moment of violence. A burst of Hawking radiation so brief and so bright that, for an instant, it becomes the last source of light in the entire universe. And then silence, perfect silence. The universe becomes a vast, empty expanse, cold, dark, starless, and lifeless. But something else happens in these final eras. As black holes shrink, their temperatures rise. A black hole with the mass of a mountain would glow faintly with thermal radiation. A black hole the size of a grain of sand would burn hotter than the core of a star. The smaller it gets, the brighter it becomes, until the final instant when the last black hole in existence emits its final burst of light and then disappears forever. After that, nothing in the universe will remain capable of producing light. No fusion, no decay, no collisions, no gravitational waves. The cosmos enters its final age with nothing left but the fading afterglow of vanished giants. The universe becomes smooth, uniform, empty. But even this emptiness is not stable, because with no stars, no particles, no black holes to anchor structure, the universe becomes dominated by entropy, maximum disorder, maximum emptiness. Time still exists, but there is nothing to measure it against. A second, a century, a trillion years, all become the same. Nothing changes, nothing happens. The universe becomes a dark, silent ocean stretching into eternity without meaning or motion. And even this is not the final horror, because after black holes die, the universe does not simply freeze. It continues to expand, stretch, thin, until space itself becomes so vast, so cold, so empty, that reality dissolves into a featureless void. A universe that no longer remembers it was ever alive. A universe that no longer contains even the faintest trace of what once was. A universe that is, for all purposes, truly and completely dead. The universe has grown old. The stars are gone. The galaxies have faded. Black holes have evaporated into nothing. Matter has decayed into dust, and even that dust has dissolved into particles that drift endlessly through the vast, expanding void. What remains is darkness, silence, cold, and entropy, the slow, unstoppable spreading of energy until everything becomes uniform, empty, and dead. This is the era of heat death, the final chapter in the story of the cosmos, a time when the universe reaches its maximum disorder, when no energy gradients remain, when nothing can happen because there is no structure left to change. In this distant future, the temperature of the universe approaches absolute zero. Not perfectly, but so close that no meaningful difference exists. The energy that once fueled stars, lit galaxies, powered supernovas, and drove cosmic evolution is now spread thin across an ocean of space, so vast that even a single particle may go billions of years without encountering another. Imagine a universe where distance has become meaningless, because everything is too far from everything else for gravity to matter. A universe where motion has slowed to nothing, where particles barely drift, where the last photons, the last particles of light, have stretched into wavelengths billions of kilometers long, diluted by the unending expansion until they can no longer interact with anything at all. Light still exists, but it cannot be seen. Energy still exists, but it cannot be used. Time still exists, but there is nothing left to measure it with. In heat death, the universe becomes a perfect equilibrium, a cosmic graveyard where no processes can occur because all differences have been erased, all gradients flattened, all energy spread evenly across a volume so large it defies imagination. In this era, even the concept of future becomes meaningless. Without change, time itself loses purpose. A second, a billion years, a trillion years, all become identical stretches of nothingness. No events, no motion, no cycles, no evolution, just a quiet, eternal dark. But there is a deeper horror here, not just the end of matter or energy, but the end of information. Every atom that once formed stars, planets, oceans, forests, civilizations, beings, memories, and thoughts has decayed. And with that decay, the information they carried, the story of the universe, dissolves too. Everything that ever happened is erased. Forever. The positions of particles, the chemical signatures of life, the imprints of ancient stars, the patterns of galaxies, the echoes of civilizations, all gone. Nothing remains but random, uniform noise. Not death in the traditional sense, but something far colder, oblivion. Some physicists believe that in the final stages of heat death, even quantum fluctuations may fade, reaching a point where the universe becomes so large and so empty that the probability of anything happening again, any fluctuation, any spark, any event becomes effectively zero. A final stillness. A cosmic pause button pressed forever. No ripples, no waves, no light, no gravity, no particles, no time. Just emptiness expanding into itself infinitely. A universe that has returned to a state more silent than the one before the Big Bang, but without the possibility of ever igniting again. And yet, even now, even in this darkness, this nothingness, this final equilibrium, the universe holds one last truth. The story has ended not with fire or chaos, not with collapse or explosion, but with fading, with quiet, with a long, slow sigh into eternal cold. The universe does not end in violence. It ends in stillness, in silence, in a darkness so complete that no memory of light remains. This is heat death, the final destiny written into the laws of thermodynamics themselves. The absolute end of everything. And yet there is one last chapter, one final haunting possibility. Because some theories propose that beyond heat death, beyond entropy, beyond the dissolution of time itself, something else may wait in the shadows of eternity. A rebirth, a reset, a new universe growing from the ashes of the old, or something stranger, the idea that consciousness, information, or reality itself might not be fully erased but transformed. If the universe truly ends, what comes after the end? When the universe reaches its final breath, when matter has dissolved, when all stars have faded into cold shadows, when black holes have vanished in silent bursts of radiation, and when even time itself has lost meaning, it is tempting to believe that nothing remains. A dark, eternal stillness stretching without purpose, without memory, without possibility. But the end of the universe is not a wall. It is a horizon, a boundary beyond which our understanding cannot travel. And beyond that boundary may lie answers more profound than anything written in the stars. Some theories propose that the universe, even in its heat-death, is not truly gone, that the fabric of space-time still holds quantum scars, mathematical potentials, hidden seeds of structure waiting for a spark that may never come. In this vision, the universe is not dead but dormant, frozen in perfect balance, awaiting fluctuations so rare they may occur only once in an eternity far longer than time itself. Other theories suggest something stranger, that the universe does not end in silence, but curls back upon itself. That entropy, though increasing endlessly, eventually reaches conditions under which space-time fractures, folds, collapses, or tunnels into a new state. In that moment, a new universe may be born not from the ashes of the old, but through the transformation of vacuum, a quantum rebirth arising from the void. A new Big Bang, a new expansion, a new era of stars, galaxies, and possibility. Perhaps even infinite cycles, an eternal cosmic heartbeat. Birth, growth, fading, death, rebirth, over and over without end. And there are far more exotic ideas, that the universe is just one bubble in an immeasurable ocean of universes, each governed by its own laws, its own physics, its own destinies. That when ours fades, countless others continue. That new universes ignite while ours is silent. That reality is larger than anything we can imagine, not linear, but fractal, infinite, recursive. That death is only a transition from one cosmic expression to another. But the most haunting idea of all is also the simplest, that even in an empty universe, even when the last particle of matter has decayed and no light remains, even when nothing changes and nothing moves, something persists. A law, a structure, a whisper in the dark. The universe is never truly nothing. It always contains the potential for something. Even the darkest void holds the blueprint for everything that once existed, encoded not in matter or energy, but in the fundamental rules of reality itself. And those rules remain long after the last star fades, long after galaxies dissolve, long after time stretches into infinity. They are the silent memory of existence, the universe remembering itself. And in that sense, nothing is ever fully lost. Not the stars, not the galaxies, not the civilizations, not the beings who once looked up and wondered where everything came from. Every thought, every life, every moment is a temporary pattern in a cosmic ocean, but the ocean itself endures. We are the universe experiencing its own story. And even when that story reaches its final page, the book remains. And the possibility of new pages always exists, waiting in the dark. Perhaps the greatest mystery is not how the universe ends, but why it began at all. Why something rose from nothing. Why existence emerged from silence. Why you, a conscious mind capable of imagining the death of all things, exist in a cosmos vast enough to fade, dream, collapse, and be reborn again. And as the final chapter closes, As the last whisper of starlight dissolves into infinite night, one truth becomes clear. The universe is terrifying not because it ends, but because it ever existed at all. And this awe, this fear, this wonder is what connects us to the cosmos. It is the fire that keeps humanity looking upward, searching for answers hidden in the stars. If you want to keep traveling deeper into this darkness, exploring the beauty and the terror of the universe with me, then stay close. There are infinite mysteries left to uncover, and this journey has only begun. Subscribe and let's continue exploring the endless night together.